Mars isn't red. Well, it is now. But for the first few 100 million years of its existence, Mars was gray. A dark, rocky, unremarkable world. Then the entire planet rusted. Today, I'm breaking down everything about Mars. No filler, no fluff, just the facts. Starting with the thing you notice first, iron. Oxide, here's something nobody thinks about. Mars is literally a rusted planet. Not metaphorically, not poetically. The surface is rich in iron oxide, mostly hematite and goethite, the same stuff that turns your old bike chain orange, except it covers an entire world. Billions of years ago, Mars lost its global magnetic field. Without that shield, solar winds started stripping the atmosphere. The iron-rich surface oxidized. Water likely played a major role back when Mars had it, and chemical reactions with atmospheric oxidants did the rest. The whole planet rusted, slowly. Over billions of years, just one big piece of metal left out in the elements. And the result isn't solid rust like you'd scrape off a pipe, it's powder. Fine, impossibly fine dust that coats the surface and mixes into the regolith. That dust absorbs blue and green wavelengths of sunlight and reflects red and orange back. That's the entire reason Mars looks the way it does. Brick-colored powder. But here's the kicker. That dust doesn't just sit there. Martian dust storms can engulf the entire planet and block out a massive percentage of sunlight reaching the surface. The whole planet goes dim because of rust particles, which is, not ideal, but the dust is only half the problem. The air itself is trying to kill you. Thin atmosphere. Here's a fun thought experiment. Stand on Mars without a spacesuit and guess what kills you first. You don't explode, that's a movie thing. What actually happens is way worse. The atmospheric pressure on Mars is about 610 pascals. That's roughly 0.6% of what you're breathing right now at sea level on Earth, 0.6%. At that pressure, you're below something called the Armstrong limit, which is the point where bodily fluids begin to boil at normal body temperature. So the moisture on your tongue, in your eyes, lining your lungs, it all starts to vaporize, not because it's hot, but because there's nothing pushing down on it. Meanwhile, you're also freezing because the average temperature is around negative 65 degrees Celsius, and suffocating because 95.3% of that barely there atmosphere is carbon dioxide. The remaining sliver is 2.7% nitrogen, 1.6% argon, and trace amounts of oxygen so small they basically don't count. Which is, not ideal, but here's the detail that makes it alive. That razor-thin atmosphere actually... During Martian winter, temperatures at the poles drop so low that the carbon dioxide in the atmosphere literally freezes out of the sky and condenses onto this. This pulls enough gas out of the air to drop atmospheric pressure by around 25%. Then summer rolls around, the ice sublimates back into gas, and the atmosphere thickens again. The entire planet is inhaling and exhaling on a seasonal cycle. It's genuinely one of the most alien weather systems in the solar system, and it's happening on a world where the air is thinner than the top of Earth's mesosphere. But if a thin atmosphere sounds rough, wait until you hear what Mars's gravity does to everything else. If you weigh 100 kilograms on Earth, you weigh 38 on Mars. That's it. That's the conversion. Mars pulls at 3.71 meters per second squared compared to Earth's 9.81, which means everything on the planet operates at 38% of the gravitational force you're used to. So you could dunk a basketball there. You could probably dunk a small car there. Great news for your vertical leap, terrible news for literally everything else. See, gravity isn't just what keeps you on the ground. It's what keeps an atmosphere on a planet. And Mars, with only 11% of Earth's mass and 38% of its diameter, simply does not have enough pull to hold onto its air. Right now, this very second, Mars is losing roughly 100 grams of atmosphere to space. Every second. Just bleeding gas into the void like a slow leak in a tire that nobody's going to fix because there's no one there to fix it. But here's where low gravity gets truly wild. Dust devils on Mars can reach heights of 8 kilometers. For reference, commercial airplanes cruise at about 10. These aren't cute little tornado cosplays spinning across a desert. These are towering columns of dust taller than Mount Everest, powered by thermal convection that low gravity does absolutely nothing to stop. And because gravity can't pull that dust back down efficiently, Martian dust storms don't just happen and end. Fine particles get lifted so high into the atmosphere that they stay suspended for months. One bad storm can blanket the entire planet in a haze that blocks out 99% of sunlight. Gravity shaped everything about Mars. It's the reason the air is thin, the storms are massive, and the planet is slowly suffocating itself. But if you think the gravity is dramatic, wait until you see what it let grow on the surface. If you stood at the base of Olympus Mons, you wouldn't be able to see the top. Not because of clouds, not because of dust, because the volcano is so absurdly massive, that its summit disappears over the horizon due to Mars's own curvature. Let that sink in for a second. A mountain so big the planet curves before it ends. Olympus Mons rises 21.9 kilometers above the surrounding plains. Mount Everest, for reference, sits at 8.8 kilometers. So we're talking nearly 2.5 Everests stacked on top of each other, which is, not ideal if you're trying to hike it, but height isn't even the impressive part. The base stretches 624 kilometers across. That's roughly the size of France. The entire country, you could drop Arizona on it and still have room left over. The summit alone contains a caldera complex with multiple collapsed craters, the largest one measuring 80 kilometers wide. That single crater is bigger than most on Earth. Here's the thing though. Despite being the tallest volcano in the solar system, Olympus Mons has incredibly gentle slopes. We're talking 2 to 5 degrees. It's a shield volcano, basically a larger, wider cousin of Hawaii's Mauna Loa. So you wouldn't be climbing it. You'd be walking uphill for weeks without realizing you were on a volcano at all. Just vibes and a slight incline, and it might not even be done. Lava flows on Olympus Mons range from 200 million to 2 million years old, and some of those youngest flows suggest volcanic activity in the geological past. By planetary standards, that's basically last Tuesday. Whether Olympus Mons is truly extinct or just taking a nap is still an open question, and honestly, the idea of a dormant volcano the size of a European country is enough to keep me up at night. But if Olympus Mons shows how high Mars can reach, the next feature shows how deep it can cut. Valles Marineris. Everyone calls this Mars's Grand Canyon. That comparison needs to die. The Grand Canyon was carved by a river over millions of years. Valles Marineris wasn't carved by anything. It was ripped open. Tectonic forces literally pulled the crust apart as the Tharsis Bulge formed, and the ground just fell away. Think less river erosion and more the planet cracked like an egg, and the scale is beyond anything on Earth. 4,000 kilometers long, 200 kilometers wide, up to 7 kilometers deep at its lowest point. That's roughly 4 times deeper than the Grand Canyon. The system branches into multiple interconnected chasms, splitting off the main trough, forming a network so massive it would stretch from New York to Los Angeles with room to spare. Here's where it gets properly alien. If you stood on one rim and looked across, you wouldn't see the other side in many sections. It's not hidden by fog or distance. It's hidden by the curvature of the planet. Mars is smaller than Earth, so the horizon drops off faster. At its widest points, the opposite rim sits beyond your line of sight. You're standing at the edge of a canyon so wide the planet curves away before you can see the other wall. But here's the twist nobody expects from a tectonic rift. The canyon walls and floor show layered mineral deposits, including sulfates and iron oxides, that suggest past interaction with water. Sediments stacked in sequences that point toward episodes of water flowing through or pooling over time. The rim-to-floor elevation difference is so extreme, it likely creates distinct microclimates, with frost and ice distribution changing as you descend. Basically, this crack in the planet may have functioned as its own self-contained weather system. So no, it's not Mars's Grand Canyon. It's something far stranger. And if water pooled inside a tectonic rift billions of years ago, that raises an obvious question about where all that water went. Hellas Planetici. If you filled this basin with water, it would create a sea deeper than anything on Earth. Let that sink in for a second. The deepest point on Earth's ocean floor is about 11 kilometers down. Hellas Planicia's floor sits roughly 7 kilometers below the Martian mean surface level. Fill it to the rim, and you're looking at a body of water that would make every ocean on Earth look like a puddle. This thing is 2,300 kilometers across. That's not a crater. That's a wound, and it came from exactly what you'd expect. Roughly 4 billion years ago, during a period called the Late Heavy Bombardment, something absolutely massive slammed into Mars and carved out the largest visible impact basin on the planet. The Late Heavy Bombardment, by the way, is exactly what it sounds like. A few 100 million years where the inner solar system just got pelted with asteroids and comets like the universe was throwing a tantrum. Mars took one of the worst hits, and Hellas is the scar. Today, the basin floor is covered in layered deposits and seasonal dust storms, with frost that builds up thick enough to be visible from Earth through a telescope. It shows up as a bright spot, which astronomers originally mistook for elevated terrain. Turns out it was the exact opposite, one of the lowest points on the planet, just covered in ice and dust. But here's where it gets interesting. Some researchers think that billions of years ago, the combination of Hellas's extreme depth and residual geothermal heat from that catastrophic impact could have created subsurface aquifers, liquid water, trapped underground, potentially persisting long after the surface dried out. Which means if Mars ever harbored life, a giant hole punched into the planet by a space rock might have been one of the best places to look. Speaking of water, Hellas isn't the only place hiding evidence of it. Mars's poles have been hoarding ice for billions of years, and the amount they're sitting on is staggering. Polar ice caps. Mars has permanent dry ice on its south pole. That's not a quirky detail. It's the only known permanent dry ice deposit on any planetary body in nowhere else. Just Mars. Both poles have ice caps, and they're mostly water ice with a seasonal coating of carbon dioxide frost that comes and goes with the Martian seasons. The North Pole is the big one, holding roughly 1.6 million cubic kilometers of water ice. That's a staggering amount. But the South Pole is where things get genuinely strange. Even during Martian summer, when temperatures climb as high as they're going to get, the South Pole retains a permanent layer of solid sea O2 ice about 8 meters thick. It just never sublimates away. It sits there frozen, being the only place in the known universe where this happens. But here's where it gets really interesting. Slice into either polar cap, and you'll find alternating bands of thin ice, some layers as thin as 10 meters. These are Mars's tree rings, millions of years of climate history compressed into readable strata. Each band represents a shift in dust deposition, temperature, or orbital wobble. The ice itself contains traces of perchlorate minerals and dust-bound salts, which tells us atmosphere and rock were interacting chemically over long stretches of Mars's past. That's not just frozen water, that's a chemical record. Now, the terraforming crowd loves to talk about melting these caps. And sure, 1.6 million cubic kilometers of ice sounds like a lot, but if you melted every drop of polar ice on Mars, you'd get a global ocean maybe 30 meters deep. That's it. Not enough to meaningfully thicken the atmosphere, not enough to kickstart a water cycle, not enough to turn Mars blue. The math just doesn't work, but if you think frozen water is exciting, wait until you hear about the two tiny moons slowly falling apart above it. Phobos and Deimos. Eggers has two moons, and they're both dying, just in opposite directions. Phobos and Deimos are, to put it generously, not impressive. Phobos measures about 27 kilometers by 22 by 18. Deimos is even smaller at roughly 15 by 12 by 11. These aren't majestic celestial bodies. They're lumpy, cratered potatoes that Mars probably grabbed out of the asteroid belt billions of years ago. Spectroscopic analysis shows they're similar to certain types of asteroids, which means Mars essentially shoplifted two space rocks and called them moons. But here's where it gets genuinely weird. Phobos orbits Mars every 7 hours and 39 minutes. That's 3 full orbits per Martian day. It moves faster than the planet rotates beneath it. So if you're standing on the Martian equator, Phobos rises in the west, streaks across the sky, and sets in the east, twice a day, backwards compared to everything else. And it only appears about a third the size of Earth's moon, so it's doing all of this while looking like a bright, fast, slightly panicked dot. It's also doomed. Phobos is spiraling inward at about 1.8 centimeters per year. Doesn't sound like much, but give it roughly 50 million years and it'll either slam into Mars or more likely get ripped apart by tidal force first. And when that happens, the debris is expected to form a temporary ring system, Saturn rings, but on a budget. Deimos, meanwhile, is doing the exact opposite. It's slowly drifting outward, gaining altitude with every orbit, and will eventually escape Mars's gravity entirely. Just gone. Off into the void. No goodbye, no forwarding address, so Mars is stuck with 2 borrowed asteroids on borrowed time, one falling in, one floating away, neither planning to stick around. Which is, not ideal for a planet that already lost its atmosphere and most of its water, but at least Mars had water once, and the evidence for that is way more extensive than you'd think. Ancient water evidence. Here's where Mars stops being a dead rock and starts being a crime scene, because thousands of ancient river valley networks have been identified from orbit. Thousands. These aren't scattered randomly either. They're concentrated in the southern highlands, carving through terrain like veins through a body. This wasn't a dry world with occasional puddles. This was a planet with water on a continental scale. The best evidence sits inside Jezero Crater, a 45-kilometer wide basin that Perseverance has been crawling through since 2021. The crater contains a delta. Not a maybe delta, not a could-be sediment. A full layered, unmistakable river delta with sediment deposits indicating sustained water flow roughly 3.5 to 3.8 billion years ago. Water poured into this crater, slowed down, and dropped everything it was carrying, exactly like deltas on Earth. But here's where it gets interesting. The minerals found across Mars include phyllosilicates, which are clay minerals that only form in the presence of water, the kind of water that suggests a potentially habitable environment. These clays date back to the Noachian period, roughly 4.1 to 3.7 billion years ago, and they're everywhere. That's a habitable environment lasting hundreds of millions of years, and the Jezero Delta specifically contains organic molecules, carbon compounds detected in the rock. Now, organic doesn't mean life. It means the building blocks were there, sitting in water with the right chemistry for an extraordinarily long time. That's as close to a smoking gun as planetary science gets without actually finding a fossil. The wildest part? Water might still exist on Mars. Recurring slope lineae, dark streaks that appear seasonally on warm slopes, were initially proposed as evidence for liquid water on the surface today. But most scientists now lean toward dry processes like granular flows or hydrated salts as the explanation. Nobody's fully settled that debate yet, which means Mars isn't just a planet that had water, it might be a planet that still holds some beneath its surface. But knowing whether anything ever lived in that water, well, that depends entirely on the robots we've sent to find out. Robotic exploration, everything you just learned about Mars, every volcano, every canyon, every ancient riverbed and ice cap, came from machines we built on Earth and hurled across 225 million kilometers of space. And the story of how we got there is wilder than most people realize. The first successful Mars landing was the Soviet Mars 3 in December 1971. It transmitted data for about 20 seconds before going silent forever. NASA's Viking 1 followed in July 1976 and actually stuck around, sending back the first clear images of the Martian surface. That was nearly 50 years ago. Since then, the machines have only gotten better. Curiosity rover landed in August 2012 and has been crawling across Gale Crater ever since, covering over 31 kilometers of terrain. It's still active, still sending data, still doing science on a planet where the average temperature would kill you in minutes. Over a decade of continuous operation on another world, which is, not bad for a car-sized robot with a laser on its head. But here's where it gets emotional. Perseverance touched down in February 2021, carrying a tiny 1.8 kilogram helicopter called Ingenuity. NASA designed it to complete 5 flights, a proof of concept. A quick demo to see if powered flight was even possible in an atmosphere that's 1% as thick as Earth's. Ingenuity completed 72 flights. A machine built for 5 cautious test hops became the first aircraft to achieve powered flight on another planet, and then just kept going. Sometimes the machines are better than we deserve. China's Zhurong rover joined the party in May 2021, but went quiet after about a year when Martian dust covered its solar panels. It hasn't been officially abandoned, but nobody's heard from it since. Add that to the list. Right now, Curiosity and Perseverance are the only active rovers on Mars. The big debate is whether we should send humans to establish a permanent base and start drilling beneath the surface, or let the robots keep doing what they've been doing. Both sides have a point. Humans can make decisions in real time. Robots don't need to breathe. Either way, every section of this video exists because a machine landed on a frozen, irradiated desert and refused to quit. If you enjoyed this video and want to see more, click the video on the screen now.